Euro HPC JU resource applications, which allowed us to have HPC in daily routine in our software unit. And what was the impact in terms of business? For us, there were specific, clear, and quantifiable outcomes. First of all, we had two innovative products that differentiate us in the market. The Pedidos, the clinical decision support system, enabled us to go to the medical software market, and the development of Dosimetry, which is the Gen AI solution for 3D preclinical dosimetry in parallel with the imaging devices. It allowed us to provide in our clients new features. It will provide, because now it is under development, and so it will enhance our product portfolio in order to include enhanced AI dosimetry. And our clients also in CRO and pharma companies ask for dosimetry calculations, and now we will be able to provide them such services. In terms of impact, I should highlight the strategic collaboration with I Know How, the Greek company that I mentioned before, and also the Aletheia company, which is a Polish startup with expertise on explainability, and we are collaborating in Dosimetry, in the FFplus project, in order to provide robust and trustworthy prediction models. Also, this experience with HPC allowed us to be partners in other EU funding proposals, providing this HPC expertise. And lastly, I would like to mention the return of investment, that we have much faster simulation times, that they can reduce the product development cycles, and also the simultaneous imaging and dosimetry can minimize the experimental time and the cost. I would like also to highlight the impact in the other companies, as I Know How, with this add-on that we provided with the Pedidos, they extended their market, adding the dosimetry feature, and also the Aletheia company, the Polish startup, it was for them a first industrial use case to exploit their solution in our application. And also GRNet, which is a member of the Greek NCC, they had a real expertise on applying their methodologies in industrial sector and in real business cases. So we foresee also impact in other levels, like to expand this methodology to other imaging devices. So it is an opportunity for us to open B2B market, so to provide this feature and this methodology to other imaging devices. And we believe that we enhance EU economy by supporting SMEs in a very highly competitive field. So in terms of innovation, it is very clear in our case that HPC enabled us as a company to a cross-platform innovation. So we utilized it both for clinical and preclinical applications. And these two tools that we provided, the synthesizer and dosimetry, which are based on Gen AI, are highly competitive and goes beyond the state of the art. And also, it is on our plans to apply in other R&D and EU funds and proposals to participate in several EU initiatives. And our goal is to generalize our methods to a broader application in radiopharma. Also, I would like to mention that through these applications, we had the chance to publish our methodologies in 2 journals, and also we had the chance to participate in several international conferences showcasing these scientific developments. And finally, to concluding, I would like to share some thoughts that, of course, there are some barriers to utilize in daily practice in a company HPC due to the costs for having many computational resources. Also, there is limited access to HPC. Even if you gain HPC access, you cannot use them for general R&D activities of the company, but they should be focused on a specific proposal. So this is also a barrier, at least in our case. And of course, there are some issues that we needed to cover in terms of training our personnel, in terms of gaining expertise in HPC methodologies. So the ways that we mitigated these barriers is that we applied in Euro HPC JU, as I mentioned, and also we had strategic collaborations with academic and industrial partners in order to share our knowledge and to efficiently utilize HPC resources. Also, we continuously try to train our personnel even through the NCC courses and online workshops that are regularly on air. And also we invested our own funds, but we aim that we will recover these costs through the products. And our vision is that HPC should be more easily and efficiently applied in daily routine in industrial applications, and to find ways to reduce costs maybe, and of course to promote cross-sector collaboration in order to create sustainable, economical and viable HPC-powered services in healthcare. So this was in a few words the story of Bioemtech and HPC, and I would like to thank you.
Thank you, Panagiotis, for this complete and clear presentation. Now we will move to Kevin Charpot from Oceanwings, which will talk about experiment to standard practices integrating HPC for sustainable maritime innovations.
Okay, thank you. So hello everyone, I'm Kevin Charpot. I'm a CFD engineer from Oceanwings, and today I will walk you through how HPC went from an experiment to a real part of how we innovate and operate every day at our company. Let's dive into how this transformation happened and how it's still shaping our work today. So let me start by telling you who we are and what we do. Oceanwings is a French SME focused on a wind-assisted propulsion for ships. We developed Oceanwings, a patented articulated wing sail system. It's a two-element rigid wing with a main element and a flap. that adjusts automatically for optimal aerodynamic performance. Our product is designed for real-world shipping, providing fuel savings and emission reduction up to 45%. We are not just reducing fuel, we are helping reshape maritime transport to be more sustainable and more efficient. So our HPC journey began with a European initiative, the FF4 Euro HPC project. And the goal was to automate and scale our aerodynamic simulations. Before that, we were doing things manually, which was time-consuming and hard to scale. I remember in 2021, when I joined the company Oceanwings, there were no HPC, no CFD. Everything was doing outside of the company. And we started also thanks to the FF4 Euro HPC project, actually. For this, we partnered with Politecnico di Milano, Cineca, Toolspol, and USI to build the infrastructure we needed. So together, we built a fully automated OpenFOAM-based pipeline for HPC clusters. Since then, HPC has become part of our everyday work. We now run automated CFD simulation for design, R&D, and custom projects. During the project FF4 Euro HPC, the name of the project was SimOcean, we have used over 300,000 core hours. And for example, on one recent project, we simulated over 150 trim combinations for a vessel in just 5 days. And that would have taken weeks before. This lets us move faster and with more confidence, whether we are testing new designs or responding to a client request. And HPC has made us more agile. We have reduced product iteration cycles from weeks to days, and we can now respond much faster to customer requests. And thanks to open source tools, we have eliminated software licensing costs, and that alone is a big deal for SMEs. The data from simulation feeds directly into our control software, which makes our sales smarter and more efficient. That means better performance at sea and better commercial results for us. And HPC also helps us to innovate. I remember when we launched our first HPC batch job, it was a big shift from doing things manually, and now it's like second nature, normal. Thanks to it, we've been able to design new Oceanwing configuration and explore more advanced setups like multiple wings on a single ship. Each ship has a different layout and constraints, and HPC helps us adapt our design every time. And this has laid the foundation for scaling our innovation beyond just aerodynamic. But it wasn't all smooth sailing. We faced some real challenges, a lack of initial expertise, complex workflows, and access issues. And we tackled this by collaborating with HPC centers, automating our processes, and upskilling our team. So while HPC can be intimidated at first, we have shown it's possible to integrate it sustainably, even as a small company. And to wrap up, HPC has transformed how we work. The FF4 Euro HPC project was a catalyst, but the transformation continues. Oceanwings is a great example of how SMEs can sustainably integrate HPC, creating real impact both in business and innovation. And looking forward, we aim to expand its use further into our design and innovation workflows. And we have a quote we like: "Innovation is the ability to see change as an opportunity, not a threat." And thanks to this project and in collaboration with Arthur, at the end of the experiment, a success story video was made, and that gave us a lot of visibility after the project. And I have just selected a few moments of the video.
We are presenting the FF4 Euro HPC success story entitled "A High-Fidelity Tool for the Optimal Design of Wind-Assisted Propulsion Technology." The results presented in this success story were produced in collaboration with the Italian National Competence Center. The development of the innovative IT solution in the experiment addressed the needs of the maritime technology manufacturing SME Aero. Aero is a French SME that has created a patented rigid wing technology, Oceanwings, that solves the environmental and economic dilemma facing ship owners, reducing their environmental footprint while remaining competitive and profitable. The Oceanwings consists of a two-element articulated wing sail generating forward thrust through aerodynamic lift. It is controlled by an automated AI-based software that optimizes the wing's angle of attack and camber in real time to maximize thrust and thereby can save up to 45% of a ship's fuel consumption, significantly reducing greenhouse gas emissions.
Aero needed a workflow for fast and reliable evaluation of the aerodynamic characteristics of different combinations of Oceanwings optimized for installation on different ships in order to overcome the limitations of a non-scalable workflow around the commercial simulation software. However, Aero lacked both expertise in the specific numerical simulation tools and the computing resources to run them at the required scale.
Partners developed a robust tool that can be used to automatically launch open foam CFD simulations on HPC systems. This replaced the previously used software with a highly scalable solution and allows thousands of aerodynamics calculations to be performed in a few hours.
This solution makes an affordable tool available to Aero to optimize the Oceanwings design and also to generate large databases with different trimming parameters based on CFD results for various wind conditions to feed its AI-based wing control software.
Improved performance of the AI onboard wing sail control software will lead to higher fuel savings and thereby to follow-up business with existing customers willing to pay for algorithm upgrades. Automation of the design workflow and use of open source code speeds up the development process by a factor of 3 by allowing the running of simultaneous computations without incurring prohibitive license costs. With improved designs and control software, CO2 emissions can be further reduced.
Improved design and thereby aerodynamic performance will make Oceanwings more competitive in terms of price and performance. A 10% increase in performance is possible with these new products, with margins yet to explore for improvements. Furthermore, easier generation of adaptive configurations allows Aero to now make competitive offers for a variety of ships.
The experiment set up an HPC-based automated toolchain and workflow for extensive high-fidelity simulations and optimizations at an affordable cost, with competitive time to solution, providing excellent results which benefit Aero and their technology, Oceanwings. FF4 Euro HPC, SME innovation through HPC. Get inspired. Visit www.ff4eurohpc.eu.
So, thank you again for the invitation. Giacomo Barigazzi, co-founder of Axyon AI. What we do at Axyon AI is leveraging high-performance computing and deep learning for portfolio management and portfolio optimization. More specifically, our company vision is that the future of investment management needs to adopt predictive artificial intelligence to bring new predictive power to drive investment performance through alpha generation. And that will impact both portfolio construction and risk management in the asset management space. Our mission as a company is to empower investors with AI, machine learning, these deep learning based technologies that deliver signals and predictive insights on which stock, which security is expected to outperform the market, and provide to our customers solutions that go across all the pipeline, or all the steps in the pipeline to build investment strategies. We started our company in 2016. We were part of the acceleration program run by ING Bank in the Netherlands. And then we raised money from ING Bank, UniCredit in several fundraising rounds during the last few years. And in addition to institutional investors such as ING and UniCredit, we also have venture capital firms based in Europe and in the US who are helping us in scaling our business worldwide. Among our partners, there are research institutions that will support us in identifying the new AI technologies that are relevant for the specific use case that we work on. We have high performance computing providers such as Cineca, NVIDIA, and other companies, and data providers, of course. What we offer to our customers are solutions that aim at providing them with signals and strategies that enables them to identify winners and losers in financial markets. We provide this via our web application, Axyon Iris, and we integrate with the infrastructure of our customers via email, SFTP, API, and so on. Thanks to the partnership with Cineca and University of Modena, we were accepted to our application to the FF4 Euro HPC program a couple of years ago, with the goal of leveraging high performance computing to empower AI and deep learning solutions for the asset management, with a project whose ultimate goal was to develop an AI-based platform that enhance the performance of asset management strategies, automating the model construction process and creating risk management features to limit the volatility of the investment strategies. The impact of this project was, on the one hand, our ability to extend and expand the number of securities in our portfolios, and integrate continual learning solutions that could help us in terms of maintainability and adaptiveness of our models. There were three main tangible business impacts that, thanks to this project, we were able to achieve: scalability, risk management, and adaptiveness of our solutions. More specifically, on the scalability, our goal was to improve the service offered by to our customers through several tech advancements in terms of scalability, parallelizing and optimizing job life cycles, handling by our machine learning platform, with the business impact of being able to expand the market coverage thanks to a wider range of securities that we have included in our model portfolios, resulting in a 25% cost reduction for model training and maintainability, and an increase in the serviceable obtainable market of 150%. So basically, thanks to this first impact that we have, scalability, we are able to serve a much larger number of companies that are using our solutions. The second impact was to develop risk management features that allow us to enable an end-to-end portfolio construction solution. So in this case, in asset management in general, there are two main metrics to consider and two main goals. First is increasing the return as much as possible, and the second goal is reducing the risk, which in financial management means reducing the volatility of the investment strategy. The second business impact was aimed at targeting this second goal, so reducing the volatility with risk management features that allow us to provide to our customers end-to-end solutions, with a business being impact in terms of portfolio construction and optimization, better risk-adjusted return profile of multi-asset strategies, and maximum drawdown that was reduced by from approximately 60% to approximately 5.5%, which is a significant impact in terms of strategy performance. The third impact regards adaptiveness of our machine learning platform and our strategies, with improved robustness to changing market conditions. With this regard, we used continual learning methods to improve the predictive performance and at the same time reducing the computational load required to for model retraining. We implemented an integration of continual learning technologies in our software in the last couple of years, with that resulted in a live reduction of costs for model training of 15 to 20K per year, increasing, allowing us to save money and to serve a much larger customer base. In addition to the three business impact that I described before, there is also an additional benefit that we were able to achieve thanks to our participation to this project, which is business I just described before, technology in terms of tightening our existing partnerships with university and Cineca, being able to access HPC infrastructure, and also to leverage Cineca and University of Modern expertise in handling the new deep learning technologies, combined with the high performance computing infrastructure and being able to adapt the low level software libraries that we use in order to train our models in parallel. Also, access to AI talent is something that is absolutely crucial for us. As everybody knows, it's extremely important for us to being able to attract people as we have, and we are expanding our team year over year. So it's important for us to being able to be attractive for new students that join our company. And third, lastly, in terms of dissemination, thanks to the participation of the FF projects, we submitted and were a few papers that were accepted and then we had the opportunity to present the results of this research in several conferences, with the result of being able to generate leads and new sales opportunity, which is of course the main driver for raising additional funds and being able to raise funds in the future. Thank you very much.
So with this slide, I want to announce the second call for business experiments of FFplus project. which specifically designed to drive the uptake of HPC by SMEs. So this means business experiments, which will address the uptake of HPC, this HPC, and the SMEs should be new to using HPC and should solve specific business challenges. So the deadline for submission for the second call is August 26th at 5 p.m. So the selected experiments are expected to start on January 1st, 2026, for a duration of 15 months. So this call offers an indicative total funding of 4 million budget for all selected business experiments, with main participant SMEs restricted to participating in only one type of sub-project. So you can have all the information about this call in this link, or when you scan this QR code, you will go directly to the link for the business experiment call.